We're going to take a look at an example with a few different parts, making use of Chebyshev's inequality here. You should have already heard this. This is just a briefer way of stating it symbolically, that the percentage of scores that are within within k deviations of within k standard deviations of the mean, meaning that not exactly equal to or further out. So within k standard deviations of the mean, we should have at least 1 minus 1 over k squared for the percentage of scores. That P is short for percentage of scores, or proportion, or probability. Okay, so first off, if we have a mean of 65.2 and a standard deviation of 7.8, then what is the minimum percentage of patients from the treatment group with pulse rates within 1.9 standard deviations of the mean? All you need to know there is that K is 1.9. And so plugging that in, we're computing 1 minus 1 over 1.9 squared. Now, you can just type this into a calculator. However, I tried out doing this a long way just to see if I would get the same thing. So first of all, I wrote that 1.9 as a mixed number, then an improper fraction. I distributed the squaring. I took the division of 1 by that. I took the reciprocal and turned that into multiplication. 1 times 10 squared over 19 squared is still 10 squared over 19 squared. So I square the 10, square the 19, I get a common denominator. And as a fraction, I found out that we'd have 261 out of 361. Well, divide, that's not a nice thing to divide by, 361. So it stopped after 10 digits. And I moved that 2 to the right to turn it into a percent. This could be just typed in to a TI-84, and we get the same thing. Moving that 2 to the right, 72.2991688%. You may be asked to round that. So watch the directions for where to round to, if in fact they want rounding. Next part. What would be the minimum percentage to be within 2.25 standard deviations? Notice that we didn't even use the mean in the previous part. And we won't here either. So that means that we could be talking about just about any set of data or distribution in both part A and part B. So I'm just going to switch K to 2.25 in all 3 spots. And if I type that into the calculator, I expect to get something a little nicer here. Let's see. So scrolling up and copying and pasting, I'm going to replace the 1.9 with 2.25. Yeah, maybe not quite as nice. All right, so 0.802469 And what else was there? 804.8024691358. It's quite likely that that's rounded as well. And so as a percent, moving that 2 to the right, $80.24691358%. Now notice that we've gone further away from the mean. K is larger and the percent is larger. That should be expected. Now here, we're asking for, well, really, what pulse rates are we talking about then? What is mu minus 2.25 sigma? And what is mu plus 2.25 sigma? Let's see if I can get this to work. Okay. Well, mu was 65.2 and sigma was 7.8. So 65.2 and 7.8. All right, let's see what we get here. $65.2 minus 2.25 times 7.8. That's a 47.65. And an 82.75. All right. So then what we're saying is that if it's not equal to or less than 42.65, and it's not a pulse rate that is equal to or more than 82.75, then you've got at least 80.24 some odd percent that are within those two numbers. And for our last part, here we're going to have to figure out K. And if we reverse what we did here, the mu minus K sigma would be the lower of those two numbers, and mu plus K sigma would be the higher of those two numbers, or the upper bound. Well, let's see here. We want to solve for K. If I take the first one, then my score minus my, well, let's see here. Let's go with the other one instead. So let's call these lower X and upper X. Then that second one, if I subtract mu from both sides, then I've got the only term that has K in it alone now. And then if I divide by sigma, K will be alone. So I've got my upper X, my upper score, minus the mean. Oop. Divided by sigma. That's going to equal K. That didn't work. There we go. Okay. So I'm going to plug in the 73.78 for the upper score. And again, what I'm doing here should work for any of these situations. Our mean was 65.2, and our standard deviation was 7.8. Well, if I put parentheses around the numerator, the subtraction in the numerator, then I can get K here. 73.78 minus 65.2 divided by 7.8. It's giving me 1.1. That's what K is. And to double check that, that should mean then that if we go with the lower bound, if we put in 65.2 for the mean, 1.1 for K, and 7.8 for sigma, we should be getting the lower score, or the lower X, of 56.62. And we're going to check that. (65.2) minus 1.1 times 7.8 was supposed to equal 56.62, and it does. So yes, K really is 1.1. So that would mean that the percent of scores that are between 56.62 and 73.78 beats per minute we can put in 1.1 for K. And what's that going to give us? I'm expecting something lower than either of the previous answers, because K is smaller than what we had in part A and in part B. So I expect something less than 72%. Let's copy this and put in 1.1 instead. So we haven't moved as far away from the mean as we did in the earlier parts. Okay, 0.17355. And what else was there? 3719. And so as a percent, move that 2 to the right. And we have the following. And again, remember to watch the directions on when you get a similar question. Do they want you to round? And if so, to what place?